Page 15, we are moving on to exponential and cubic functions. This is going to be 15A, since we are going to use the textbook again. And our goal is to be able to recognize exponential functions based on their table, graph, or equation, and graph cubic functions given roots. So once you have that copy down, we are going to move to page M111 from your textbook. And we're going to take a look at this scenario. So the class president, vice president, and treasurer of a high school count the ballots for the homecoming king election. The election result is generally kept a secret until the pep rally, when the winner is announced in front of the entire senior class. Unfortunately, this year's ballot counters are not very good at keeping a secret. The very next day after counting the ballots, each ballot counter tells two of their friends in the senior class the election result, but makes each friend vow not to spread the result. However, each of the ballot counter's friends cannot keep a secret either. The following day, each friend of each ballot counter shares the election result with two of their friends in the senior class. This pattern continues for the entire week leading up to the pep rally. Number 1, create a visual model to represent this problem situation. Describe the patterns you observe. So go ahead in this empty space and draw some kind of a model that represents the situation, and then describe the pattern you see. If you are not doing this and you're waiting for me, just read the problem again and try it by yourself. So we know that the class president, the vice president, and the treasurer are the first 3 people. The class president, the vice president, and the treasurer are the first 3 who know what's going on. Then those people tell 2 people. And then those 2 friends tell 2 friends. And then those 2 friends tell 2 friends. Then these are going to tell 2 friends. And that's as far as I'm going to go with this pattern. So what patterns do you observe? Well, I notice that each friend tells 2. Which means the number of people is doubling each time. Like we have 3 people that know this first day, then 1, 2, 3, 4, 5, 6. Then we have 2, 4, 6, 8, 10, 12. And then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That know the next day. Okay, so based on that pattern, let's flip to the back. It says, how many new seniors will know the winner of the homecoming election on the 4th day? Explain your reasoning. So go ahead and give this a shot by yourself. Okay, so I'm going to go with a table to explain my reasoning. So at the end of day 1, there were only 3 new seniors who knew the results. Then those 3 people told 2 people each, giving 6 new seniors. Then those 6 seniors told 12 new seniors. And then those 12 new seniors told 24 new seniors. So explain your reasoning. 24, since the pattern is doubling. Okay, number 3. The total number of seniors in the senior class is 250. If the ballot counters knew the election result on Monday, will every senior already know the winner of the election when the result is announced at the pep rally 6 days later? Okay, so let's see what that means. 6 days later means that we know on day 1 how many there are, and then 6 days pass, so we're talking about a total of 7 days. So see if you can figure out all by yourself if everybody would know if there's 250 in the class at the end of day 7. If you have not paused this video to try it yourself, you need to do that now. Okay, and I am just going to add on to my table from up here. So after 5 days, it would be 48. After 6 days, new seniors would be 96. And then on the 7th day, there would be 192 new seniors that know it. But would there be enough total to meet 250? So what you would have to do is you would have to add all of these numbers of new seniors together. So we have 3 plus 6 plus 12 plus 24 plus 48 plus 96 plus 192. And if this number is bigger than 250 or is 250, then yes, everybody would already know. If you add that up, you get 381. So yes, everyone would know. Okay, setting that aside and going back to these notes, go ahead and with that table that we created, fill in the number of new seniors that here that day, that column right there. So day 1, there's 3, and then 6, and then 12, 24, and 48. So what is the pattern here? We're multiplying by 2, and then multiplying by 2, and then multiplying by 2, and then multiplying by 2 again. So there is a multiplication pattern. And anytime there is a multiplication pattern, then it is going to be exponential. Now we have to fill out our graph. So the independent is the number of days that pass. The dependent is the number of new seniors that here that day. And we're going to do the best we can to graph our points. This is just numbering by ones here. So at 1, there was 3, about here, give or take. At 2, there was 6, about here. At 3, there was 12. At 4, there was 24. And then at 5, there was 48. So it's not going to be perfect, but what you do want to see is the quick increase in those numbers. So exponential functions you probably haven't seen before, so there's not going to be a brain dump for these notes. So exponential functions are y equals a in parentheses b to the x power. And you need to know what these letters stand for. Let me make my b a little bit better. So a is your initial amount. B is your multiplier. What number is being multiplied by for your pattern? A couple things you need to know about your multiplier. If B is bigger than 1, then your graph is increasing. It would look something like this. If B is bigger than 0 but less than 1, in other words, it's just smaller than 1 but a positive number, then your graph is decreasing. And it looks like this. What you need to know is that your graph never gets to 0. Okay, state the following end behavior of the following. So y equals 2 times 4 to the x. How do you know what the graph is going to look like? Well, you look at your multiplier. This multiplier is 4. 4 is bigger than 1, so your graph is going to be increasing. So filling out the end behavior, as x goes to negative infinity, where does y go? And as x goes to positive infinity, where does y go? So this arrow here on the left, it keeps going and going and going and going and going. Well, it never goes negative, so it just goes to 0. And this graph is going up towards positive infinity. Y equals 4 times 1/2 to the x. How do you know if it's increasing or decreasing? This 1/2 right here is smaller than 1, so it's going to be decreasing. So as x goes to the left, this arrow points up, so y goes to positive infinity. And over here, as x goes positive, your arrow just keeps going. It never goes negative, so it just approaches 0. Okay, so make sure you have that for exponential functions. And we're going to go to the back to cubic functions. Okay, we have talked about cubic functions before, so this would be a pretty quick review. So we know that cubic functions are ax cubed plus bx squared plus cx plus d. What you need to know about cubics is they're going to have 3 roots. If it has a positive a value, it looks like this. If it's got a negative a value, it looks like this. How do you know that? Because anything that's has an odd exponent, it follows the same thing as a line. So if a line would have a positive slope, that means you'd have a positive a value. If a line would have a negative slope, that means you'd have a negative a value. Finding roots in factored form, same thing as with with quadratics. You set f of x equal to 0. You set each element equal to 0. And then you are going to solve for x. So let's take a look at this example. Set each element equal to 0. I just sneak a 0 in there because it's already y. So we're going to set 2x minus 3 equal to 0, 4x plus 7 equals 0, x minus 9 equals 0, and then you solve for x. So we're going to add 3 to both sides and get 2x equals 3. Divide by 2, x equals 3 halves. We're going to subtract 7 from both sides and get 4x equals negative 7. Divide by 4, x equals negative 7 fourths. Add 9, x equals 9. Same thing, graphing using roots and end behavior, just like for quadratics. You're going to find and plot the roots. You're going to sketch the end behavior. According to your a value. And then you are going to just sketch the remaining parts of the graph. And then one more thing you can remember to do is you can find and use the y-intercept as an extra point when sketching your curve. So here's what the back of your notes should look like. Here's what the front of your notes should look like. And then your textbook page should look like this. And make sure this textbook page is labeled 15B.